Okay, class, picking up where we left off. We need to finish up this fraction here, which is 144 all over 324. Now, we have the prime factorization of 144, which is 4 2's and 2 3's. Now for the 324, we have 2 2's and 4 3's. Now we simplify. We have one set of 2's in common, two set of 2's in common, one set of 3's in common, two sets of 3's in common. So we're left with in our numerator 2 times 2, which is 4. And our denominator, we're left with 2 3's. 3 times 3 is 9. So your final answer here is 4 9's. And by the way, this is supposed to be a 4. For some reason, it made it into a 9. So this is supposed to be over 324. Okay, now, we scroll down here to multiplying fractions. It says in words, the product of two or more fractions is the product of their numerators divided by the product of their denominators. In algebraic language, is if a over b and c over d are fractions, then if we take a over b times c over d, it'll give us a times c over b times d. Now, they want us to simplify this to the lowest terms. Now listen, this is how I would approach the problem. Instead of multiplying straight across, why don't we take the prime factorization of these numbers first? Like take 14. 14 is 2 times 7. And 10 is 2 times 5. So now, when we multiply them, our numerator would be 2 times 7 times 2 times 5. That's still multiplying 14 times 10. Now we go down here to the 8 and the 21. 8 breaks down to 2 and 4. And then 4 breaks up to 2 and 2. So we had 3 2's for the 8. And 21 breaks down to 3 times 7. So we will have 3 2's, a 3 and a 7. And now we can simplify. These 2's will simplify out. This 7 and this 7 will simplify out. And these 2 2's will simplify out. And we will be left with 5 over 6. Okay, now we take a look at b. Before we could do any type of simplifying, we need to change these mixed numbers to improper fractions. So, the first thing we would do here, we know that this 3 and 3/4, the denominator will remain 4, and our numerator will be 15, from what we were shown previously. Now here our denominator will be 5, and our numerator would be 8. Now, we need to take the prime factorizations. Now, let's do this. I'm going to write the fraction here. First of all, we know the prime factorization of 4 is 2 and 2. And we already know 5 is prime. The prime factorization of 8, we see as these 3 2's. And the prime factorization of 15, we know is 3 and 5. So it'll be 3 times 5. And then also 3 2's. Now we can simplify it. Oh, actually is nothing that simplifies with this 3. So that line there was a mistake. And let me take that out. Let me take this line out here. Okay, now what we do have in common, we have this 5 and this 5. And we also have 2 sets of 2's. Now, with our numerator, we had 3 times 2 is 6. Our denominator, everything is simplified out. When everything simplifies out, that leaves you 1. It doesn't leave a blank, it leaves 1. So 6 divided by 1 is 6. And that is your final answer. Okay, now we scroll down here to dividing fractions. Dividing fractions have the same principle, except for you would change your division sign to multiplication and take the reciprocal of the second fraction, or as some of you may have learned, flip over the second fraction. Now we go down here to A. Okay. That's a little computer glitch here. Okay, took care of the computer glitch. Let's do this now. We will have 45 over 16. Division becomes multiplication, and we take the reciprocal of the second fraction. Now, 45. We can take the prime factorization of 45, which is 5 times 9. And 9 breaks down to 3 times 3. So the prime factorization of 45 is 2 3s and a 5. Now the prime factorization of 8, we already know from previous problems that breaks down to 3 2s. So we don't have to rewrite that again. We have that in previous problems. Now 16. Now we know 8 times 2 is 16. So 16 actually breaks down to 4 2s. Now finally for 35. Now we could write 35 out here. 35 breaks down to 5 times 7. So now we simplify out what we have in common. We have these 5's in common, and we have these 3 sets of 2's in common. So now for our numerator, we will have 9. Our denominator, we will have 14. Okay, now we come to B. Now we do this the same way we did when we multiplied mixed numbers. First of all, you keep your denominator the same. Now we multiply. 6 times 5 is 30, plus 3 is 33. 1 times 10 is 10, plus 1 is 11. So now we keep this first fraction the same, change division to multiplication, and take the reciprocal of the second fraction. The prime factorization of 33, we know is 3 times 11. 3 is prime and also 11 is prime. And in previous problems, the prime factorization of 10 is 2 and 5. Now in our denominator, 5 and 11 are both prime. So we can simplify out these 11's, and we can simplify out these 5's. So our numerator would be 6, our denominator is 1, and our final answer is 6. And now we have objective 6 and 7. We're adding and subtracting fractions with unlike denominators. It says rewrite the fractions as equivalent fractions with the least common denominator. Add or subtract the numerators, put in this result over the common denominator. Now, this is what we could do. We could use prime factorization. Prime factorization of 6 is 2 and 3. Prime factorization of 8, as in previous problems, is 3 2's. Now, what we would do is we would match up what we have in common. We only have one set of 2's in common. You would count that once. The other 2 2's you would bring down, and you would bring down this 3. So the least common denominator is actually 24. (24) would be your new denominator. Okay, now to get your numerator, you ask yourself, you would take your new denominator divided by your old denominator. 24 divided by 6 is 4. So you have to multiply your numerator by 4. 5 times 4 is 20. Now in the traditional sense, what you would do is you would multiply your numerator and denominator by 4. Whatever it took to multiply to your denominator to give you 24, you have to multiply your numerator by the same value. And the same thing here. 8 times 3 we know is 24, and 3 times 3 is 9. So we have 20 over 24 plus 9 over 24, which is 29 over 24. And since they don't ask us to write this as a mixed number, we could leave it as 29 over 24. Now we go over here to B. 15 and 10. 15 breaks down to 3 times 5. 10 breaks down to 2 times 5. Now, the only thing they have in common is one set of 5s. So our common denominator would be 2 times 3 times 5, which is 30. So our common denominator is 30. So we look here. We say 15 times what is 30? We can multiply the top and bottom by 2 here. And 10 times what is 30? Multiply the top and bottom by 3 here. So 2 times 7 is 14. 3 times 3 is 9. Now this is supposed to be a 4. So it'd be 14 minus 9, which is 5, over 30. Now, we know 5 and 30 both have 5 in common, so we could divide both by 5, and that would give us 1/6. So our final answer here is 1/6. Okay, now we scroll down here. Now we have 5 12s plus 5 18s. Now we look here. 12, since we did this in previous problems, we know this breaks down to 2 2s and a 3. And 18, we know it breaks down to 2 and 2 3s. Now they have one set of 2s in common, one set of 3s in common. So what you would end up with is you would write that 2 once, then you'll bring down the 2 that did not match up, and you'll write the 3 once. So 2 times, wait a minute, oh, and it'd be another 3, because this 3 did not match up. So your common denominator, or least common denominator, is 36. So you say 12 times what is 36? We know that's 3. So 3 times 12 is 36. 3 times 5 is 15. Now we say 18 times what is 36? We know 18 times 2 is 36. And 5 times 2 is 10. So our final answer here would be 25 over 36. Now we come here to D. We have here a mixed number. We have 3 3/4 minus 2 1/3. So this is what we could do. We could find a common denominator of 4 and 3. So we know 4 prime factorization is 2 and 2. And 3 is already prime. They have nothing that matches up. So your common denominator would be 12. So what we will have here is 3 have a denominator of 12. 2 and a denominator of 12. Now, we say 4 times what is 12? We know it's 3. 3 times 3 is 9. And then 3 times what is 12? 3 times 4 is 12. And 1 times 4 is 4. So now we take 9 12ths minus 4 12ths, which is 5 12ths. And 3 minus 2 is 1. So it's 1 and 5 12ths. Now we scroll down here to example 8. It says determine whether 27 over 35 is a solution to the equation 2/9 n plus 1/3 n equals 3/7. Okay, first of all, we know the common denominator of 9 and 3 is 9. So we have 2/9 n plus, this denominator would be 9, and we know 3 times 3 is 9, 1 times 3 is 3, equals 3/7. So 2/9 plus 3/9 is 5/9. So we have 5/9 n is equal to 3/7. Now what we could do is, to get n by itself, we could multiply each side by the reciprocal. So we'll multiply each side by 9/5. So these will simplify each other out, and you will have n is equal to 3 times 9 is 27, and 7 times 5 is 35. And that is your final answer. Okay, class, this is example 9. A number decreased by 1/4 of itself. So we would take x, which is a number, minus 1/4 of itself. So it would be x minus 1/4 x. Now what I did here, I have this formula here I substituted, and I will complete this on the next video.